Hi, I'm Paul. Welcome back for another Blazor build. Today we're going to build an accessible switch component for Blazor, adhering to the ARIA authoring practice guidelines for the switch pattern. Currently on screen is the finished switch. I have added it a few times to show it both with and without its label and additional state information for sighted users. All of the switches bind to the same variable. As we are going to implement this according to the ARIA guidelines, a screen reader at minimum should simply announce the name of the switch and whether it is on or off. A switch is not a checkbox, and a screen reader should not announce checked or unchecked for a switch. Let's turn on NVDA, a free screen reader, and listen to what it sees.
Airplane mode, switch off. On. Off. 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 Toggle disabled state button. Airplane mode, switch unavailable off.
For the disabled state, do not use the normal disabled attribute. Use the ARIA disabled attribute and style the component as if it was disabled, handling this state in code. Using the normal disabled attribute takes the control out of the tab order, and as such it may be missed by the user. Right, let's code it up and see how it all works. Like my last few videos, I have created a Blazor interactive server application and then added a separate Razor library project to the solution called Blazor builds.components. You can use any of the interactive templates and you do not need to use a separate project. I tend to do this in my videos so you can see how all of the pieces fit together. Plus you can also turn the separate project into a NuGet package if need be. I have added my usual folders to the web root for the assets, which in this instance is just a CSS file. I have also added a couple of associated folders for the Sassy CSS files. Given this is a small component with only 4 CSS classes that we need to add to our markup, I will not bother to create my usual global strings file for all of the string constants. I have also added a reference to the component project from the server project. The file on screen is the app.razor file from the server project. I have added a link to the style sheet called main that we will create in our component project. In the SCSS folder, I have just added 2 partial files and the main Sassy CSS file for the use statements. If you have not used Sassy CSS before, I created a short 4-minute video showing how to configure this for Visual Studio. The link to that video is in the video description below. In the root partial file, I have just added one CSS variable for the focus color. As this is something that could be used in other places, I have included it in this separate file as a best practice, making it easy to be able to change this value globally at either design time or run time. The switch partial file is currently empty and is where we will add our CSS for the component. The main file just holds the use directives for the partials, so they are included in the output. The first thing we need to do is to add a folder for our component, so let's create a folder called switch. Next we need to add a Razor component. Let's name it switch. As our component will have very little code, we can just use the single Razor file approach. For the look and feel of the switch, you can add whatever parameters you like or simply change the CSS. In this video, I will just concentrate on the important parameters. The switch has no child content, so we do not need any render fragments, it's just regular parameters. As there isn't much code or markup needed for our switch, we can just add all of the code, markup, and then do the styling last. The label parameter is a required parameter and is what screen readers will use to announce the name of the switch on setting focus to it. We will map this value to the ARIA label attribute, so screen readers will be unaffected if this value is not displayed on screen. Label visible is our parameter that indicates whether or not we should display the label value on screen. The onText and offText parameters are for the state values for sighted users to make it easier to see if the switch is on or off. For example, a Wi-Fi switch may show connected and not connected. Screen readers announce on or off for the switch based on the ARIA checked attribute, so we will just hide these from the screen reader. The switch state parameter is what we will use for two-way binding. The event callback parameter switch state changed is required by Blazor for two-way binding. By convention, Blazor expects an event callback parameter with the suffix changed to match the name of the bound property. We add a private field to hold a shadow copy of the switch state to follow best practices for Blazor, which recommend using auto-backed properties to negate issues directly updating parameter values within the property set. Next, we add a method to raise the event, first checking that the switch state value is different to the one that we hold and that the component is not in a disabled state. We pass the new switch state in the event arguments. We use the onParameters setAsync event handler to ensure that the label value is not null, empty or white space. As the developer using the switch may have changed the state of the switch in code, we check the switch state parameter value against our shadow field and the disable property, calling raise on switch state changed if necessary. There are two events that we can use to check incoming parameters: setParameters async and onParameters setAsync, which also has a non-async version. The former happens before the parameters are assigned the values provided and before the one-time oninitialized event is raised. The latter happens later in the lifecycle, after both of these events and after the parameters have been assigned their values. I tend to use the latter as it's simpler to get the values from the parameters as they have already been assigned. That's all the code we need, so let's add the markup. I use the BEM block element modifier naming convention for CSS and will quite happily write markup adding the class names without having the CSS, or vice versa, as for me I find that BEM simplifies component creation. Unlike most switch components found on the internet, we will use a button and not a checkbox to create our component. We will give our button a class of switch, which is the block part of BEM, and set the attribute type to button in case it's in a form, so as not to cause any form submissions. Following the ARIA authoring guidelines, we will assign the button the role of switch and toggle the ARIA checked attribute based on our private switch state field. The ARIA attribute expects a string, so you cannot just assign it a Boolean value. We attach the button's onClick event to our raise on switch state change method, passing it the inverse of the current switch state. We assign the required label parameter value to the ARIA label attribute to ensure screen readers always have access to this value in case the developer wants to hide the on-screen value. And finally, we map our disabled parameter to the ARIA disabled attribute. Next, we include a span with the class of switch _label to hold our label value text, the double underscore indicating that this is an element in BEM. We only include this span if the label visible parameter is set to true. The next span with the class of switch _rocker, another BEM element, is what we will style to create the switch track and the rocker. Finally, we check if the on and off text parameters have been provided, and if they have, we include these within a span, toggling the appropriate value. We mark the span with the ARIA hidden attribute to hide these values from screen readers. Let's add the appropriate using statement to the server's imports.razor file and add our component to the home page. We can add our component to the home page simply by using drag and drop. Now that's all done, let's run the app and style it using hot reload to see the changes. I have adjusted my windows so we can see all of the appropriate information while we do the styling. First, we add our switch class, the block part of BEM. We will add some CSS variables to reduce typing. Normally I like to add CSS variables to the root pseudo class so I can change the values and then have a global effect on all elements that use the values like a theme. But as these 4 variables are specific to the switch, I have only included them here. We need to reset the button style, so we remove its margin, padding and borders. As we only want a specific part of the button to react to mouse clicks, we first remove the pointer events by setting them to none for the entire button. For the label and text classes, we assign a font size and some padding. Labels will appear to the left of the switch, with the text state values appearing to the right. For those not familiar with Sass, the ampersands just denote the parent selector, so where we have ampersand _label, the compiler will create a class called switch _label, along with its curly braces and contents. For the rocker class, which in effect is our track, with the sudo before element being our actual thumb or rocker, we will assign a display of inline block, giving it some height and width. By using the same height value for the border radius, we can create the rounded ends. This is the part of the button that we want to react to mouse clicks, so we set the pointer events to all. The sudo before just creates a circle and adds a bit of shadow to it that we can use for the rocker. Currently we have a button that can receive focus but has no border or outline to indicate this. Interaction will only happen on our span, the switch's rocker. We use the focus within sudo class on the switch class so that when the button receives the focus, we can show the focus on the switch's rocker. We use the same code for the hover state when over the switch's rocker. Please note that in this instance I used the CSS variable focus-clr from the sudo root class defined in our root partial SCSS file. This was to highlight that you may want to use this in many classes on other components, so having it in a place where it can be globally changed at design time or runtime is extremely useful. To make our switch move for the on and off states, we change the position of the rocker when the ARIA checked attribute is true and place the rocker to the right of its position. To make this a little better visually, we add a small transition for the move as well as for the change in track color. Finally, we target the whole button and its contents when the ARIA disabled attribute is set to true, making it appear dimmed by using the CSS brightness filter, and target just the rocker part, changing its cursor to not allowed. And with that, we are done. I will alter the home page to match the demo we saw earlier and run the app.
Airplane mode, switch off. On. Off. 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 Toggle disabled state button. Airplane mode, switch unavailable off.
Any comments, good or bad, are always welcomed and any support appreciated. All of the links for the code, the NVDA screen reader or the video on setting up Sass in Visual Studio are in the video description below. Thanks for watching. Until next time, bye for now.